3.9 Introducing Specific Heat, CV and CP. We are going to introduce specific heat at constant volume or CV and specific heat at constant pressure CP. The specific heat at constant volume is a thermodynamic property. It is defined as the change in internal energy with temperature at constant volume. So it is related to the temperature dependence of internal energy. So physical meaning of the specific heat is the energy required to raise the temperature of a unit mass of a substance by 1 degree while the volume is held constant. So unit of the specific heat is kilojoule per kilogram per degree Celsius or kilojoule per kilogram per Kelvin. Similarly, the specific heat at constant pressure is defined as the change in internal energy with temperature at constant pressure. It is related to the temperature dependence of enthalpy. So physical meaning of the specific heat is the energy required to raise the temperature of a unit mass of a substance by 1 degree while the pressure is held constant. Consider a rigid tank containing air. It has 1 kilogram. The rigid tank indicates the volume remains constant. 0.718 kilojoule is required to raise the temperature of 1 kilogram of air by 1 degree Celsius. That is, the specific heat of air at constant volume is 0.718 kilojoule per kilogram per Kelvin. Now consider a piston cylinder device containing air. It has 1 kilogram. The piston is free to move. 1.005 kilojoule is required to raise the temperature of 1 kilogram of air by 1 degree Celsius. So the specific heat of air at constant pressure is 1.005 kilojoule per kilogram Kelvin. So the specific heat at constant pressure is greater than specific heat at constant volume. This is because the additional energy is required to do work against the pressure. So compare the two systems. Temperature of both systems are raised by 1 degree Celsius. But for the piston cylinder device, additional energy is used to do the expansion work. The unit of specific heat is kilojoule per kilogram Kelvin. So what is the value in kilojoule per kilogram degree Celsius? So Kelvin temperatures equals Celsius temperature plus 273.15. So 1 degree Celsius equals 274.15 Kelvin. 2 degrees Celsius is 275.15 Kelvin. So the change in 1 degree Celsius equals 1 degree Kelvin. So we conclude that kilojoule per kilogram Kelvin is identical to kilojoule per kilogram degree Celsius. The specific heats are properties. They can be determined if the two independent intensive properties are known. The specific heats of some materials are listed in the table A19. This is a part of the table. The specific heat of ammonia is 4.818, mercury 0.139, refrigerant 134A 1.434, and water 4.211, or 300 Kelvin is 4.179. The specific heat varies depending on the materials. Water has a very high specific heat. What that means is it takes a lot of energy to raise the temperature of water. And the specific heat is dependent on the temperature and pressure. So if the temperature change during a process is small, the specific heat may be assumed to be constant, as the temperature dependence is weak.